them to crowbar them so that if it goes over voltage, it'll shut down and not damage your equipment. Well, when it took the lightning strike, that became a dead short. So that was bad. And the SCR was hard to find and expensive, which was another bad problem. But the good news is, on the new board, which I put in the supply, the SCR is on that board, which is a real plus. And the drive transistor, which was mounted to the back, is also on the board. So if I replace the board, I don't have to worry about the bad SCR. I don't have to worry about the bad drive transistor. I don't have to worry about the regulator chip. And just buying 2 of those parts with the shipping would cost me 20 bucks. And I can order this board from Astron for about 20 bucks. So how can you go wrong? So it has most of the components. So let's take a look at that. So here's that schematic again. All right, and oops. The other side. I know there's a way I do this. It just takes me a while to figure out. So over here, those transistors are the ones that are mounted on the back here. So those stay there, right? We're not going to mess with those. We can pull them off. We can test them. This is that SCR. Was mounted on the back of on the bottom of the case. It's now on the board. I don't have to mess with it. It's now on the board. This is the drive transistor. The drive transistor was mounted on the back, and it didn't meter good for me. I thought it was probably bad. So I knew I had to, at the very least, I had to replace this and this, but I don't have to do that because they're going to be on the new board. So that saved me a lot of work. And then the rest of these parts here, those are in the chassis as well. So everything else is on the board. And I don't need to, and we already talked about the fact that we metered the transformer and the rectifiers, and we can test the transistors. So if I replace the board, I basically replaced everything else, right? Makes life really, really easy. All right, so now moving on. So here's that exact same supply up and running on the bench. What I do, I remove the bad SCR, I remove the bad drive transistor, cleaned and polished everything, relocated those rectifiers, replaced the main board, and put on the power pole connectors, and there it is. Questions on any of that so far? Yeah.
So the question is, how often should we actually look at these, at the power supplies and see if it does need a set of new caps or something like that?
I would say if it's, these things stay working for decades, right? So if it's working, don't touch it. The old saying, if it's not broken, don't fix it, right?
Okay.
So, that's my feeling on most things, if it's not broken, don't fix it. I have fixed several of them. They do break for various reasons. That one was particularly old, and with all the extra wiring that went between the board and the SCR and the drive transistor and all that sort of stuff, it was also had less RF immunity. So some of them, people use them in HF stations. You might find that they're a little RF sensitive. I put extra caps in them when I put them back together to make sure that we have good RF suppression. And by getting rid of all that extra internal wiring, it cleans it up a little bit. And other questions before we move on? I mean, we'll come back. We'll have plenty of time for questions. I got more show and tell. So we talked about the diode shrapnel case. So, and actually, so this is the one I was talking about. K1IW is moving it between two different shelves in a repeater site, and the shorted out that transistor, blew up that diode, and of course it had stud rectifiers through the bottom. So again, I popped those up inside to make it a little safer, and I just replaced that diode. I actually stole that diode off of this board. I'll pass this board around. This is a slightly newer version of the board. This board actually has the drive transistor up here. Yeah, it's got the drive transistor up here. So this is a slightly different version of the board. That one's actually missing. If you look at this corner of the board, you'll see it's missing these two diodes. If you locate the IC socket, you can see there's nothing here. That's because I stole the diode off of that board to fix the other one. It would have been nice to have replaced the board, but I couldn't get rid of, I didn't have time. It was just kind of real quick, fix it, be done. So that one's put back together. That was an RS-35M, put together. It's all happy working on the bench. We've got a little bit of a load on it. I had, at that point, I only had a small load board that I used. Now I have a much bigger load board. So, this is actually the story of this power supply. So this power supply is RS-20. The person who gave it to me said the main rectifier was probably shorted, which it was. I metered it, it was shorted. Transistors look good, the caps look good. I replaced the main bridge rectifier because I happen to have something in my jump box that, how many of you guys have a jump box of parts? Okay, how many of you have at least one big bridge rectifier in there? Yeah, there you go. See, that's what I did. And I replaced the main board. Actually, the second board that's going around is the board that came out of that. And you can also see that there's some burn marks by the IC socket as well. So whoever was having fun with that, with this supply before I got it, definitely had some fun with it. And of course, this one's now working fine. So I've sent around the two boards. The new board has most of the parts on it, including the drive transistor and SCR. And really, it's cheaper to just buy the board with all the parts on it than buying a few of the parts individually at this point. I mean, it's fantastic that that Astron actually offers you the board. Now, I will forewarn you that the boards are different between the 25, the 30, and the 50. So when you call them to order a board, it's best to tell them which one you want so that you get the right one, because there's different values for some of the holdback resistors, and also the heat sinking on the drive transistor is different between the 20 and the 35. They have way more heat sinks on the drive transistor for the 35, but they charge the same price for it. Okay, so let's see, I didn't, don't have that drive transistor to send around. I keep thinking it's in here, but I never can find it, so I don't know what happened to it. Should be in here, but it's not. So on that one, I put the digital, put the digital meter on it. By the way, when I ordered these, I think I ordered like 10 of the digital meters. So if you want some of these digital meters, I have a couple of spares here that can be yours for, I don't know, $10 or so. If you want to add a digital meter to something, because they're $5 plus shipping when you order them. So if you're going to replace the board, there's only, well, it depends on how you count the connections. There's the first 3 connections, which we don't make anymore. And if you look on those boards, there's numbers like 1 through 7. And then there's 2 connections that go right to the capacitor. For the final drive, you move it from the old board to the new board. That drive wire goes right to those transistors on the back. The 2 big wires, the 2 little wires from the transformer supply slightly higher voltage to run the regulator than what the path transistors run at. The plus and minus go across the cap. You basically just bolt the new board where the old board was removed. And now you have what I call 2 and 3 bigger. They're much bigger holes because now you're running the full current through there because you're going up to the crowbar and the sense circuit right there. So I put in, if I can, a 12 or a 10 gauge wire to those bigger, to those holes. So next thing, the transistor I passed around is a 2N3771, which is what Astron recommends. One of the supplies I have has 2N3059s on them. Not quite sure why somebody did that. It's a slightly lower rated transistor. 2N3055s we're used to as kind of a real workhorse transistor. It only has about half the power handling capability that you need in terms of current handling. And W5 BWC likes the 2N2586s, but I've never found a cheap source for those. So before we go too much further, let's talk about having some fun with some more test equipment. So here's another meter. This is probably my favorite meter. I got this at Jamiko. How many of you guys have ever ordered anything from Jamiko? Jamiko Electronics in San Leandro, California. When I was living out in California, I actually, Will Cole ordered some stuff and picked it up. And in the lobby, they had this on a special sale, and I just had to buy it. But what's really cool about it is over here, you can plug in a capacitor. This was my first meter that you could meter capacitors with. I thought that was cool. And then you could plug a transistor in here, and it would give you the HFE or the beta of the transistor. I thought that was really cool. And I thought this was cool because this was, back when meters like this were like a couple $100. This was like this was like an $80 meter. And I was really thrilled about that. And I was so thrilled about that right up until about the time when I got this meter, which does almost all the same for free from Harbor Freight Tools. So we'll start things here with you, but you'll get backed up pretty quickly. And I thought that was really cool until I found out about these things. So here I have what I call the magic tester. I always wanted to have an ESR meter. And back when I was a bench technician working in the lab, if you had a capacitor ESR meter in the lab, I mean, that was like a $1,000 piece of equipment. You know what ESR stands for? Yeah. Equivalent series resistance, so it's how much resistance the capacitor has, which should be 0, but it actually has some resistance. Well, I was looking around for cheap ESR meters, and I found this. I put this in a case by myself, and I put the leads on it. But what this is it will identify a capacitor, a resistor, an inductor, a transistor, or a FET. You connect the leads any way you want, and it tells you what it was. It's like, wow, I wish they had this stuff. And you know what? You can buy one of these things on Amazon, Banggood, or eBay with or without a case, with or without a color display, from about $10 to about $30. So really, and they're all about the same. So where'd that transistor go? Did it get stopped over here? All right. We'll take the transistor. We'll take the magic tester. We'll come over here. You can hook the leads up any way you want, hit the button and see what happens. So that can make testing stuff really fun. And then also, wherever that big cap ended up, if you discharge the big cap, you can put the big cap, yes, that really huge cap on that tester, and it'll tell you the capacitance and the ESR of that really big cap. And it'll even measure things that are down in the picofarad range. I measured some feed-through caps that I was using on something else just the other day. But if you really want to test one of these supplies, want to load test a 35 amp supply, what resistor do you need to load test a 35 amp supply at 12 volts? What do you need? The answer is up there. About 0.3 ohms. How do you get a 0.3 ohm 600 watt resistor? Well, you take a 50-foot extension cord, that's a 16 gauge extension cord, and you short one end, and now you have 100 feet of 16 gauge wire, which is about 0.4 ohms. You have yourself a really big resistor that you can run 600 watts through and load test your power supply if you wanted to. So you can get really cool fancy test equipment like this $10 to $30 magic tester, as I call it, or you can just use an extension cord. So you can have a lot of fun with those things. And then finally, since I fixed so many of these things, if you want to get fancy, you can start making yourself a load tester. So this has a voltmeter and an ammeter on it. It's nice for testing batteries or power supplies, and depending on which switches you throw, you get just under 2 amps, just under 5 amps, just under 10 amps, and another 10 amps. So you can get up to about 25, 30 amps that you can pull out. If you've got thick enough wire, I have a couple of clip leads on there now. You lose a lot through the first section of clip leads until you get the 10 gauge wire. But it's a good way of testing these supplies or testing batteries. So you can get as fancy as you want with what test equipment. Like I said, we could start with just that 40-year-old analog voltmeter. We could do all the repair just with that. So, some recommendations. Fix things. Isn't that what ham radio is all about? Building things, fixing things, taking other people's trash and making it your treasures. When in doubt, replace the board. Why? It's cheap. It's got all the parts. Also, the summary of my talk is just replace the damn board. It's easy. So, look around flea markets for the transistors. I happen to have a bunch of the 2N3771s that I ordered, actually 2 suppliers. At some point, I want to put together like a curve tracer that I can run up to about 10 amps and see how the different transistors. I bought one set from China, hoping that they'd be counterfeit and they'll come up really bad. And I bought another set from a U.S. supplier. I like the 91% running alcohol as a cleaning fluid. It cleans just about everything. So pause for just a second for questions before I go on to a slightly another part of the topic. Oh, all right. So sometimes I get asked about switchers. Well, Astron does have some nice new switchers out. I actually have 2 of them, one working, one not. So I found a good article, interesting topic. They start by feeding power back into the output for some of the initial measurements. And you need an isolation transformer for some other things. Maybe next year I'll actually get around to fixing it. I've done a couple little things, but never gotten far enough for what I want to do. So we've already done a bunch of the show and tell. So I showed you some of those. Oh, like I said, if I've got a bunch of these little digital meters, and if somebody wants to buy one from me, I have a few more up here, but we don't need to pass around more than one in a bag and one out of the bag. And okay, so I didn't bring any bad transistors with me today. I probably should have done that. But did everyone find that the transistor worked? Was it easier with the magic tester? Yeah. All right. So let's move on to some Q&A. Will I fix your supply? No. But I do have some repaired ones here if you're interested. So a lot of people, because there's a chip in there and it's socketed, people want to replace the chip. Well, I have yet to find a bad one. And I came up with, I found somewhere in my collection of things, I found this really neat little 5-volt supply. And it turns out it has a socketed 723 in here. And every one of the 723s I pulled out and put in here, the supply always makes 5 volts. So I haven't found a bad one yet. But I use this as my IC tester for that regulator. So I pass this around, or people have seen open frame fly out. It's always fun to pass stuff around. I brought it here, you might as well pass it around. You know what, we'll pass this around too. So that way everybody gets some exercise, right? So, have I ever had a problem with the 723 chip? Yes, there's a funny story with that. So this supply I use in my shack. Why? Because I have so many of these supplies that if I ever need a supply somewhere and I can't find one, I just take another one off the file and I use it. And this one's nice because it's got all the connectors on it and a voltmeter so I can see what's going on. But this one I like using more. Why? Because it's lighter. And I was using it to test something on my bench, and all of a sudden it had no output. I was like, that's not allowed to happen. I fixed it. It's not allowed to break again. Well, it turns out that the board, the replacement board I got from Astron, when they soldered in the IC socket, they didn't quite get it all the way through the holes in the board. So it was just kind of leaning out a little bit and mostly making contact. And, you know, it's like you push on the board and it works and it doesn't work, works, it doesn't work. And then I saw that the IC socket, instead of being nice and flat like that, was like this. And so I heated up the joints and I pushed it all the way through the board, and now it's just working fine. But that's the only problem I've had with one of the 723 chips. And I have a couple up here that have been kind of mashed around for a while and they'll still work just fine. So, with that, some thanks to the Minuteman Repeater Organization for their donation of many, many supplies that I have fixed for them. There's a nice article on Repeater Builder by Tom Daly, which is where I learned about the fact that you could buy a new board and put it in there. There's also another article by W5BWC, who says, yeah, throw out the entire board, throw everything out, and redesign it my way because I'm better than they are. It's way more work. It's just easier to replace the board. So I wouldn't really necessarily go with that. And so I'm just going to wrap up at this point. There's my contact information. And we'll take some more questions or play with show and tell, and we'll start over there, okay?
Okay, so I've got an Astron 35M.
Okay.
And
it hums.
It hums. It sounds like a 60 cycle hum.
Yep.
If I touch the barrel connector of the coax,
yeah,
everybody says the hum goes away.
Cool.
That grounded up the wazoo. Also make sure I don't have a ground loop.
Yeah.
If I switch to a battery,
yeah,
hum's gone.
Okay.
If I put another power supply on,
yeah,
hum's gone.
yeah.
go back to the 35, and the hub's there.
Okay.
What would typically something like that be?
So, so there's a couple of different places we could go with that. So the first I'm going to go with is something that I only more recently learned and forgot to talk about. So on some of these supplies, and you can't really tell which, but like on this supply, there's the plus, the minus, and a ground stud, right? You can see the ground stud there.
Yep.
This supply, there is no ground stud. So on both of these, we really don't know if the ground, if the DC minus is connected to the AC ground in the chassis or not.
Mm-hmm.
So someone else I was talking to had the brilliant idea of marking all their supplies as to whether or not they have bonded grounds. And one of my switchers, which I'm using, I actually intentionally went in there and cut it so it's an open ground, so I don't have AC ground issues between my DC radio equipment, my DC ground, my RF ground, and my AC ground. I can keep them as separate as I need to. So the first thing I would do is look at your supply and see is it a bonded ground in that supply or not, and if it is a bonded ground, maybe unbond it, because floating the DC is never a bad idea. To separate your DC, usually your DC and your RF ground on your radio equipment is the same, and separating from the AC ground is probably a good thing. I've seen AC power line grounds with several volts on them, so it's they're pretty bad.
So would it be advisable then to the grounding rod, run it right to the DC ground?
Well, your DC ground and your RF ground should be connected there, but only if you're separated from the AC ground, because your AC, yeah, and your AC ground, you could create hundreds of amps going through that path if things are really bad in your house. There's a factory not too far from here where they were supplied with power from this power company in that town on this end of the building, and this power company at this end of the building, and at one point they connected their grounds with big bus bars, and they melted. So ground is not always ground, and keeping your DC and your AC ground separate is not a bad idea. So I'd look at that first. I'm not saying that's the issue. I'm just saying I'd look at it to see if it could be an issue. The big stud rectifiers, maybe you have one of those that's bad, or maybe those two little diodes. We go way back to a schematic. These two diodes here, that's one of those two that blew up. Those supply, you can see there's a secondary, another secondary. It's this one all the way at the bottom and that one all the way at the top. Sorry. The inner ones are the big stud rectifiers. The outer ones supply a slightly higher voltage to the regulator. If you lost one of those two, you could be putting a ripple right on your regulated signal. So I would check those two little ones on the board. I would check the big ones. I have an ESR tester, so I check the big tap. But, the 60 hertz hum really does sound more like a ground thing, especially if you touch it and it goes away, it really sounds like it's a ground thing. I've also seen on these older supplies, you're only as good as these connections if they're not really tight, and you can see these ones, you can actually see they're copper. I actually cleaned those up with Grasso when I took the supply apart and rebuilt it. One supply I fixed for someone, I didn't fix it all because there was nothing wrong with it, and he realized later that he had an intermittent connection in one of his cables. And that's why it wasn't working.
So the other test I was doing is I took a 10,000 farad cap
Yeah,
and went from positive to negative.
yeah, and
It went away.
so maybe the big cap inside is bad, right? Because these are like 20,000 microfarads on the outside.
Microfarad?
I forget what it is. What? Yeah, 20,000 microfarads. Yeah. So I mean, maybe you're big, or that if let's see if we look at the next picture. So this is the RS-20, which has two capacitors next to each other like this. But have you tried checking if those screws are tight?
No.
Why don't you check that? Because if those screws aren't tight, you're not making, there's a capacitor under the board. And if you have a little bit of tarnish under those screws, that cap's not making contact. So, you know, take it apart, check the big cap with any meter you want, check for some tarnish on those screws, and check and see if your ground is bonded. Those would be, because those are all free, and that's 10 minutes worth of time. Your question, if he has follows up, we'll come back.
We talked about, you have to have supply the linear supply, which is pictured up there.
Yep.
We also mentioned switching supplies.
Yep.
What's the difference? And obviously switching is less expensive. Why? And which one should you really be looking at?
Okay. So, without getting into too much too many details of, so this is the schematic for this. It's way simpler than a switching supply would be. There'd be a lot more parts in it. This thing here is the transformer. It's why these things weigh more than that little kid over there. So the good news is they're heavy, they don't blow away in the wind. The other good news is being a linear supply, people tend, other than his, which is humming, people tend to think they put out cleaner power. Because they don't have a switching supply, can put out a lot of RF radiation. I'll explain why in a minute. But this transformer does the big job. It takes the 120 volts or so, and it steps it down to about 18, 20 volts here, and then it regulates down the rest. And that's done, through the pass transistors and the big capacitors. 2200 microfarads in this schematic, anyway. Or 2200 microfarads. So, very simple. These things literally last forever. The drawbacks, they're very heavy. They're more expensive now because when it comes to manufacturing, weight equals cost, right? And there's one other drawback to them. If you're going to leave it, even if you don't have a load on the supply, if you leave this plugged in with very little load or no load on it at all, you will see it on your electric bill. It has a little bit of energy that's being absorbed in that transformer, and in the transistors it's being passed out as heat, and you're paying the electric company for that. Now, it may only be, an extra $1 a month that you're paying for it to be on in your house all the time. But on the other hand, if you're a small radio club and $1 a month makes a difference on your electric bill for your repeaters, maybe that's something to consider. And the more power you draw out of them, the more they dissipate in terms of heat, they have these nice big heat sinks on the pass transistors, and that's energy that's being wasted as heat as part of the regulation. So a switcher is a more modern power supply design, and what they typically do is they take the input voltage right at 110 volts or 220 volts, and they rectify it right there. And so now you have some very high voltage stuff sitting in there. And then what they do is they have a switching circuit, which it's kind of like the name implies. It's like if you had an incandescent light bulb and you could flip the switch on and off really, really fast, it would look dim as opposed to bright. So it's the same concept, except for instead of a mechanical switch and you flip in the switch as fast as your arm will make it, you have typically a MOSFET in there that is turning the power on and off a couple hundred thousand times a second. Well, that's the HF bands, and then it radiates upward from there. So that's why they produce RF noise. And so it's switching on and off really fast to make a lower voltage, and then that's going into some inductors and capacitors to filter. And that's very, very oversimplified description, because there's a lot more to it than just that. But the good news is it's light because we don't have the big heavy transformer. We maybe have a little transformer that we're sending this signal at 100 kilohertz or so through, but then it can be a much smaller transformer to be efficient. And it's lighter, it's more efficient because it's not putting out heat. It just turns on longer to keep it more power going through and off less of the time. If it's only has to put out a little bit of power, it's on only a little bit of the time. And so it's more efficient. They don't kick out as much heat. Unfortunately, all those capacitors in your switching supply are seeing that ripple of it turning on and off. Does anyone know how capacitors are rated for life? Anyone have any idea? We'll look at the ratings of capacitors. So a capacitor is typically rated anywhere from around 1,000 hours. What portion of a year is 1,000 hours? Much less than a year. So a capacitor is rated at less than a year's worth of life at a particular temperature, let's say 85 degrees C, at maximum ripple. Then there's a derating curve from there. So chances are, as you're not at 85 degrees C and you're not at maximum ripple, then you're up at 10 or 100,000 hours worth of lifetime. But in your switching supply, you'll start to have capacitors fail very quickly, as opposed to like the big capacitor I passed around. These things last decades in a linear supply. You're obviously adding some show and tell, so I'll let you steal the stage.
So, here's some of the view for our YouTube version. Down in the bottom, 25 amp switching supply. Right? So it's not a very big space. You see it's a really small, light supply compared to this guy, 35 amps, a little bit bigger, right? So halfway between there and here on the other supply. So it's much smaller. There's a lot of cheap Chinese switchers out there. You want to use caution, right? This one is designed for radio work. As a matter of fact, this supply they use in commercial two-way radio, right? So it's pretty well filtered for what we do as amateur radio operators.
Can I pause you for a second?
Go ahead.
It's for use with what type of radio?
VHF and UHF.
VHF and UHF, either digital or FM.
Right.
If you're going to work HF,
You want to be very careful.
you have to be very careful because HF, your LED lights will interfere with, your fluorescent lights will interfere with, your switching power supplies will interfere with, and, you know, the power supply for your computer and charger for your phone, those are all switching supplies. So if you're operating HF, you're running around the house unplugging things to figure out what's making noise. But, well, okay, but for your VHF and UHF radios, you're right, switchers are much easier to deal with. I'm sorry for interrupting you, but I thought that was...
That's an excellent point. You really do have to be careful with the quality of these. And I'll give you one quality example. Our club trailer, right? Found this beautiful shore power supply. Something you put in your boat or your RV, you put it in the club trailer. And it had a built-in 12-volt DC supply. Was it 50 amps or something? It was a very respectable supply. The minute you turn it on, wiped out the entire HF thing. Made it absolutely unusable. So we decided, well, we're going to build a filter for that. The other issue was weight. So we had an 80 amp supply, Bill? 70 amp aspirant supply. We wanted to take that out of the trailer and filter the switching supply in the shore power unit. By the time we got done with the toroids that you needed to make the common mode choke and the input and the output, that supply and that shore power supply weighed as much as the 70 inches. Heck with that.
If I remember right, that power supply came out of an RV. Well, it is an RV supply.
Right.
And it had an RV rating, an RF rating.
Well, yeah.
Yeah.
But when I called the company, they said, yeah, it's got the rating. The manufacturer told us, and they wanted nothing else to do with talking at all. Yeah. And by the way, the guy that I talked to was a ham.
Yeah.
So he knew exactly the minute I got him on the line, he knew what I was talking about. And basically, he didn't tell me to forget about it, but that's certainly where the conversation ended up.
And you can get some nice 12-volt switchers. Oh, and that's the other thing to watch out for when you're looking at cheap switchers. You can get some 12-volt, really nice 12-volt switchers. And you know what they are? 12 volts. What's a ham 12-volt supply? 13.8. And you know what? If you're using these VHF and UHF radios, can change your output power quite a bit. When you drop, it'll operate down to 11.9 maybe, but your output power could go down quite a bit. So if you're going to operate HF, the other thing is like I said, these Astron linears are literally impossible to kill. I mean, the one that was hit by lightning I've been using, that was this supply. That was hit by lightning, and I've been using it for quite a few years after I repaired it. I just decided that I have too many supplies sitting in my basement. Anything else? Any questions, comments? People want to play with some of the stuff or ask them?
So, one question. So I'm going to start looking at the 35.
Yeah.
On the drivers going to the heatsink.
Yeah. There's one drive transistor. Oh wait, that's 20. I was looking for a picture of the inside of the 35. That's the 20.
So it's on the back side.
Yeah. So if yours does yours have an external drive transistor or an?
Yes.
It does. Okay.
So
yeah, it's a I forget the name of the number of that transistor. It's probably on
could the Mylar have dried out or?
Oh, okay. So the drive transistor or the sorry. So the drive transistor is the tip 120. Are you talking about the drive or are you talking about the pass transistors?
Drive.
Okay. This is the drive transistor.
Right.
The ones up there in the blue circle are the pass transistors. So the drive transistor is a tip 120. It's on the new board as opposed to mounted to the back with long wires. If I had any questions about one with a stud SCR in the bottom and an externally mounted tip 120, I just replace the board. And guess what? When you replace the board, you'll be cleaning up those contacts to the big capacitor. And I'm gonna bet, just from what you've told me, I'm gonna bet that you've got a little bit of oxidation on the board where it mounts the board to the cap. I have a couple of audio amplifiers at home, and there's one that it's like it works, it doesn't work, it works, it doesn't work. I finally found that I had a bad connection on one of the 2N3055 TO3 transistors with just, it looked connected, but it wasn't. You know, a little bit of corrosion can really bite you in the butt.
You talk about the past transistors and the care and feeding, heat sinking, compounds.
Okay, so the four pass transistors, which are circled with the blue at the top, or I can circle them again. These are the four pass transistors. Now you'll notice they all have emitter balancing resistors on them, which is nice, so that they don't have to be 100% perfectly matched. If you have, you know, this has 4 of them, this has 2 of them. If you take away one of the pass transistors, it'll still work. It just won't get as far. You might get all the way up to the 35 amps. You might not. So it's tough to know when one of those is going. The can of them is hot, right? It has positive voltage on them. The heatsink is grounded, so obviously you need an insulator between them. So there should be a mica insulator underneath them. Nowadays you can use a mica insulator, or some of them you can use like a plastic insulating pad, which is also passes thermally, and you use a tiny, tiny amount of thermal grease. The thermal grease can dry up, but if you don't disassemble it, it's still making good thermal connection. If you do disassemble it, you've broken that bond. It may never rebond thermally. So if you take out one of the transistors, clean it all up with alcohol, get all of the paste off, everything, put your mica insulator back in, put it all back together properly, make sure everything is mechanically tight. Use some new heatsink paste, not too thick, because you don't want to liquid cool it. You want to have it just transfer the heat from one surface to the other. So that comes under the old saying, if it's not broken, don't fix it. Don't take them apart unless you need to. And if you do take them apart, make sure you're getting a good thermal connection. I don't know if you want me to expand on that any other way.
That's just what I was looking for.
Yeah, so I don't think I brought any mica insulators. I do have some in my stash of parts at home. It's probably, he said he had some 2N3055s in his junk box, so he probably got some mica insulators too. And I actually had, interestingly enough, so these are black anodized aluminum heat sinks. Is the anodized aluminum conductive or non-conductive? So the black anodized coating is insulated. I actually repaired not an Astron, but something else where like something was working for a really long time, and it was even working on my bench before it blew up. And what blew up was there was a TO3 transistor screwed into an anodized heatsink, no insulator, and it was working fine. And all of a sudden, that little black layer decided to get a pinhole in it and conduct and short out, and then you have a power to ground short, and as they say, it's spitch and sparking. But, you know, you do find these things, and you can find something that's been in service for 10, 20 years, and for some reason was just missing an insulator, and actually, this was on an audio amplifier. I got two of the same type of audio amplifiers, and I had the factory schematics for them. Both of them had the same build error. Not the missing insulator, but again, on the audio amplifier, there's a chassis ground, a power ground, and an audio ground. One speaker was between the speaker bridge output and audio ground, and the other speaker was between the audio bridge output and chassis ground. And between chassis ground and audio ground, there was an inductor and a capacitor. So it kind of worked. But it took a while to notice, and it's like, okay, well, they built both of these wrong. So I had to put them together so that the right ground was the right ground. So I know you want to think that ground is ground, but your lightning ground, your lightning ground is a protection ground. Your AC ground is so hopefully you don't get electrocuted, and your DC ground is for your equipment. And your audio ground is your audio ground. And that's how you avoid ground loops, by keeping them separate when they need to be. Anybody else? Anything else? You guys have fun with the show and tell?
Very good.
All right. All right, so I emailed him a PDF of the slides. If you guys want to share that, I don't know how the PDF came out. And sorry, I projected from my Mac instead of your PC, but it gives me a little bit more flexibility. And I hope it came out okay for the YouTube audience, and we got some audio and some video. All right, and like I said, if people want to take home some of my toys, I don't get rich on this stuff. I just have fun, sharing things and defraying some of my costs. All right.
Okay, thank you. All right, thanks everybody for coming, and for our YouTube audience out there, apologize for the delay in getting on the air. For the club members, watch your email for our minutes from last month and financial report. At this moment, I have another presentation. Chris, front and center. Bring your meter with you. Okay. Face the camera there. Let's come right in front of the podium. All right. And hold up your meter for the rest of the YouTube land to see. All right, you got that last month. We have another anonymous donation for you, or if the person wants to be not anonymous, that's okay. We have a set of test leads, so you can actually use it, and some resistors and LEDs, so that you can start experimenting with Ohm's law. And remember, you have to use a resistor with an LED so you don't blow it out. But you got to figure out which one to use. So, congratulations again, and thanks for coming.
Thank you.
All right, anything else? Anybody? Questions, comments? Bill, go ahead.
I know you're going to send out the email for the minutes, Could you do it before the meeting?
That would be a good idea.
Okay, yeah.
Yeah, okay. So the question was, can we send the minutes and the financial report before the meeting? And that's what was my intention. However, you know how tight it is. So thanks much. I appreciate that. We'll get that done. Anything else, anyone?
Let me just touch on Joda, why he didn't have it.
Joda, again, we were late in the planning, but we did get a hold of the scouts. The question is, why didn't Joda happen? We did get a hold of the scout folks at our exec board meeting that night, and it was a couple of weeks before they had their roundtable meeting. An announcement was made, and we had indicated that we wanted to have, some sort of RSVP so that we could figure out how big of an operation we could put together. We had Camp Split Rock reserves, and we could set up a large operation if we needed to. And I got absolutely zero interest from the scout troops directly. So I figured we'll out there and set up all the stations we want, but they'll be showing up. So we did give them, a day or two notice that we would be canceling, and with the district executive and the scouts. We also did leave the invitation open to have something bigger, better next year, and we get started much sooner. And Ken had suggested June of next year. I like the idea of much sooner than that. Ken, you had a question?
Yeah, not a question, just a comment. So I did reach out to a couple of additional scout masters, and they said if we can start planning it in March, so that they can get their schedules and how much they need, as well as work with the scouts, and give them a handout, number of handouts. That would be the best way to do it, so that come September, we'll know we'll get it in there, it'll be already in their schedules, and they'll be able to plan accordingly. Also, the Nashua Radio Club is going to do another launching of a balloon to coincide with JOTA next year. And that's a high altitude or low altitude balloon, I don't know what it is. And essentially you have to talk with somebody who's at NASA through the balloon. And it's tracked with HD cameras on the balloon. And so they're trying to, that as well, get interest with JOTA.
Okay.
So we'll start thinking in January, and we'll put something together maybe for February, March timeframe.
That sounds great. And, let's get these ideas together. We'll start working with the district executive even sooner than that, to let them know the direction that we're thinking and find out if it's meet their goals as well. And then we'll start formal planning after January, February. So we want to be way ahead of the curve and partnering with Nashua and, of course, our friends at the Mohawk Club as well. It's a great idea. So, if we can really start out much earlier, and, there's no reason why we can't even think about a JOTA weekend where the scouts are out there camping. And you've got activities all day Saturday, and introductions on Friday night, and Sunday closing, and the whole kit and caboodle if they want to take it that far.
So I started Saturday, not on Saturday, and total spoke to 51 scouts, varying from 20 meters up to 15 meters. Hardly anybody was on 15. But got 51 scouts, and then Voice of America came in, and there were over 3,000 connections. And then it was connecting over to UK, Spain, things like that, and it was quite interesting listening to it.
We're talking about Jamboree on the internet?
Yes. No, Jamboree on the air.
Okay.
It was on the air, not on the internet. And it was quite interesting listening to it. And there were some scouts, some Weeblos, some Girl Scouts. Quite interesting.
Well, we'll just start out much earlier. Does that answer your question, Bill?
Yeah.
Very with the Mohican Council, and now National Valley Council is part of the Worcester Council. This year has been very, I work on the commission staff at the Scout office, and it has been horrendous. We stuff like that, bridging two councils together. So that actually has become Joe on the air wanted being on the bottom of the pile, basically. Nashville, which is 6,000 stuff down in Cape Cod, 2 weekends ago. So this year has been very, very horrendous. Yes.
Thank you for what you do for the scouts, and, then we work with you next year.
I was the one in contact last year, basically, I was the person that went down into the office. They changed staff, council office, they're merging two councils together, it was just crazy, this year.
Are they gonna be closing the scout office up there?
It's gonna be operated basically as two different districts. There's four districts basically behind that. I have to go to Rutland tomorrow night for a meeting, so I didn't know where Rutland is, because that's where our Canadian Commission is. So yeah, they merged two councils together, and there's a lot of stuff that goes together. Actually, Rutland, yeah.
No, go ahead.
Yeah, two more things, if you don't, voice about a few things. Okay. The tape measure antenna that dropped, probably not gonna get picked back up by Mark, because I think he's no longer employed at the hospital, I think he moved on someplace.
Okay.
If anybody wants to do the tape measure antenna, I'll head it up, I know how to make them, and we can do it in my garage.
Okay.
I am not interested in fox hunting, so I'll go as far as the antenna, and that's it. And the second thing is, on November 3rd, Indonesia is having a special witty contest, 15 meters only. And you get special points if you get a wide beat lane or something like that. Should be a very interesting contest if 15 meter opens. That would not be a bad contest to do for the trailer. One radio, just ready, plug it into the pole so we don't even need a generator. Shoot the beam right over the North Pole. See what happens. If anybody wants to get together and do it. I mean, it'd probably be a total waste of time, and it might be a lot of fun.
Right. So, you'll pick up for the YouTube audience, you pick up the tape measure.
Yeah, if anybody wants to do it, I'll do it with them.
All right, so we'll get that out on the,
Yeah.
for lack of
I
a
mean,
better
I know
term,
Jack
newsletter
wants
with the
to
rest of the stuff.
Tape measures, I can probably get 100 tape measures in the club now.
Yeah.
And maybe we can get the parts from Mark and stuff, and I'll pick it up.
And at least the parts list of what people need to.
Oh, he's got all the parts.
And then I can bring the spectrum analyzer down. We can do the tuning of them with the spec am. And that's cool and easy and quick.
Yeah.
So it gets them right on the money. And of course when is the contest?
Contest November 3rd.
Okay,
I'm
November.
gonna do it from home, but if anybody wanted to get together as a group, we can do it at the trailer.
Yeah. And, what was the country?
It's Indonesia.
Okay, Indonesia RIDI contest on November 3rd.
Yeah.
And where is the trailer right now?
Trailer's in Baldwinville.
Oh, okay, all right. So one radio, RTTY, throw it up on the beam.
Yeah.
Let's see what we can do.
Should be cold, but if it is, I'll put pants
I'm not going to put that out on the air.
on. Gary went out.
All right, anything else, anybody?
You guys want to talk something?
No.
We used to.
Yeah, we used to have a great time.
1994, 96.
Yeah, I was with a group that did a lot of fox hunting, and there's all kinds of other cool things you can do, like time of arrival antennas and things like that.
Yeah, it's amazing how you can fox hunt with just an HT buried in your chest. It just doesn't have to be fancy. Yeah.
A lot easier.
Yeah, exactly. Where's the station? It's directly behind you. All right. Anything else, anybody? Welcome back. Been seeing you a long time. Okay, folks. Thanks for coming, and
Thank you.
we'll adjourn the meeting.